have the questions where you're supposed to pick from, but here, according to the instructions, the constants are given. Section A, they're saying for each correct answer, 2 marks will be given. For each wrong answer, 0.67 will be deducted. For no answer, 0 mark will be given. The minimum total mark for question 1 is 0. Yeah. Question 1 says for each correct answer. Okay, we have read this. We have in an equilibrium problem, the point about which the torques act is computed or are computed. In an equilibrium problem, the point about which torques act are computed. So option A says what? Must. Computed must through the object center of gravity, may be located anywhere, must pass through the end of the object, one end of the object. Then D, they are saying must intersect the line of action of at least one force acting on the object. Kasoma, which one do you think is the correct answer here? Or B? Because they're saying in an equilibrium problem, the point about which the torques act are computed. So B, Godfrey is saying B, may be located anywhere. Then D, okay, so A is off, because A just restricts us to talk about the center of an object. So A is out. Then C, must pass through one end of the object. That's also out because it can be anywhere. So the correct answer here is B. Yeah, so B is what is justifiable because it caters everything. Yeah, so that is going to be our best choice here. So yeah, question 1, we are saying the answer is B. This is our option. Then look at number B. An ideal gas is heated at constant volume from 300 to 600. If the original pressure was 1.5 atm, the new pressure is going to be what? So what will be the new pressure? So we use that formula under your gases. Remember when what? The volume is constant. Remember when the volume is constant, we just have this. This is the equation that we're going to use. This is something under thermodynamics, the last topic. I know this concept was also learned in chem, but it comes back here in physics as well. It still applies. This is an ideal gas that we are discussing, so this part can also be followed. So we want to see what happens to the pressure, right? That's what they want us to do. The pressure is initially 1.5. So I'll put my 1.5 atm. Then the T1 is 300. It's already in Kelvin. Then what happens? What are we going to get as our P2 when here we have what? We have a 600. So when you cross multiply, what is your P2 going to be? When you multiply 1.5 by 600 and divide it by 300, what do you get, guys? Godfrey, hope you're having your calculator. What do you get? Kasoma, what do you get? Okay, so Godfrey is getting a 3, so that's a 3 atm. So if you notice, it was 1.5, so meaning it has what? It has doubled, right? So the correct answer here is going to be A. That's what happens. So we've done the calculation to check out what happens. So this is what we're going to get. Then the next thing is they're saying at constant temperature, when temperature is constant, the pressure and volume of a gas are what? Are they directly connected or inversely proportional to each other? So this is the same thing again. We look at the formula, the overall expression when temperature is what? When temperature is constant. So when temperature is constant, we say P1 and V1 equal to the P what? We say P2 and what? And V2. Yeah, so if we just talk about P1, look at what the answer is going to come from. So this is going to be P1 is put K there and V1. So these are inversely related to each other because they're on the same side, right? If they were directly related, they would have been on opposite sides. Yeah, so the correct answer here is supposed to be A as well. That is what you're going to get as the correct outcome. Yeah, so that answers our part C. Yeah, then the next one, look at number D. They are saying a modulus of elasticity is a ratio of. So here, what's the modulus of elasticity? What's the expression that we use? Godfrey, anyone, guys? What's the modulus of elasticity? Anyone, guys? Any try? This is something that you learn under what? This is what you learn under mechanical properties of matter. Yeah, so what do we get here? Anyone to give it a try? So modulus of elasticity is just the comparison of what? We say stress over strain. Yeah. So the ratio that we want to show here, look at what we have on top here. They're saying stress to deformation, stress to strain. So the only one that makes strain sense here is B, the ratio between a ratio of what? Stress to what? To strain. So the correct answer here is going to be B. Yeah, this is simply asking about Young modulus. That's the first modulus of elasticity that you ever check, or rather learn. Yeah, this has to do with something being elastic, meaning change in the length. Yeah, because the deformation could have happened with reference to volume, which is called Buoyancy modulus. But here, the question specifically wants elasticity, meaning we're dealing with a hard material that we're trying to affect. So that's why we're saying the answer is supposed to be B. Yeah, so hope this is okay. Then look at E. E here says the product of force times the perpendicular distance between some point and the line of application of the force is. Yeah, so the product of force. So we have force, right? Times the perpendicular distance. So if you have a force, this is your force there, and the distance has to be perpendicular from the force. When you multiply these two, what do we call it here, guys? What's the answer going to be? What's the answer here?
It's the torque intercept.
It's a torque, right? Yes, torque is the one that gives us this. So here, the direct answer here will be C. So our answer is torque. Then look at number F. In inelastic collision, neither momentum nor kinetic energy is conserved. Momentum and kinetic energy are both conserved. Kinetic energy is conserved but not momentum. Momentum is conserved but not kinetic energy. What's the correct answer here? Which one do we go for? Mumezi, what's the best pick here? What? I'm unable to get you. A. Is everyone agreeing with what she's saying? Only momentum is conserved. Kinetic energy is what? Momentum is conserved, but kinetic energy is not. Is there anyone who has a different opinion? So it's supposed to be this guy here, only because the only equation that you have, Kylie, in inelastic, if you remember, we said the equation is supposed to be M1 U1. So momentum is still going to be conserved because you have this equation, but we don't have a proper equation that can join what happens before and after in terms of kinetic energy, because the guys are not separate this side. You cannot create a kinetic energy equation that involves both masses like this. To say we have this, then V squared, then this side have half M1 and U1 squared. This won't be true, yeah, because of this part here. This cannot hold, yeah. So the correct answer here has to be D. Momentum is conserved, but not kinetic energy. This is only under inelastic. But under elastic, both kinetic energy and momentum are going to be conserved because the guys are still what? They're still separate. Yeah, hope this is okay, guys. Hope this is okay. So we move on to the next part. The next part here says buoyancy occurs because with increasing depth in a fluid, what happens? What's buoyancy, guys? We said buoyancy is what? What's buoyancy? What's the definition of buoyancy? Anyone, guys? What is buoyancy? How do we define it? Anyone? Godfrey? So we just said buoyancy is like the normal force in a fluid, guys. Buoyancy, it's like when you try to submerge something in water and it comes back up to float, the normal force that an object feels when placed in a liquid is what we call buoyancy. Yeah, so it entirely depends on the depth, on the depth in the fluid, because the pressure increases. Yeah, as you move away from the surface of the liquid that you are dealing with. So our correct answer here is supposed to be A, because the pressure is more. Yeah, because of, you say the weight. Remember we talked about the weight. The weight is simply supposed to be what? The same weight you lent is, we have what? Weight is this. So buoyant force is simply the same as the force due to the weight. So we talk about what? We talk about, is it having potential energy? We say the potential energy, which is just going to be something like this. This is buoyant force. Yeah, this is the buoyant force. So the force that something has, which is the weight that it has, only the weight is acting on something. Imagine we don't push it in the liquid or the fluid. And the height is going to make variations in terms of how much buoyancy we are feeling. Yeah, if you put it a little bit close to the surface, it will just move quickly here with small amount of force, right? You put it very far from the surface, it will come back up with a lot of force because of the distance that it was. Yeah, so buoyancy is going to be increasing whenever there is pressure increase due to the increase in the height. So the answer there is A. Then H says an acceleration which is constant in time results in a velocity which is what? What's the answer here, guys? What's the correct answer?
So when the acceleration is constant, meaning the velocity will be increasing, that means it will be changing linearly with time, and the answer here is C.
The answer here is C, right? Because if we maintain the y, so meaning it makes us go back to the whole equation of velocity. Yeah, I know the first temptation here is to think that when acceleration is constant, it means that the velocity has to be 0, but then it's the other way around. When velocity is constant, that's when acceleration is 0. So in this case, we are saying it changes linearly with what? Time, because we have final velocity is equal to the initial acceleration and time. So this is kept constant, meaning the whole idea of velocity is going to be entirely dependent on time, and it's going to be a linear expression because the highest power is going to be 1 on t. So the answer here makes it to be what changes linear with time. The answer here is C. Hope that's okay. Then number I, they're saying a vector quantity defined as a change in velocity of a moving object during a given time interval divided by time interval is what? How do we call this guy here? We know it's acceleration, right? But the change, we're saying the change in velocity. So change in velocity with change in time. So is it instantaneous or average velocity? At least I've cancelled out A and B, so you don't have to be tempted by A and B. So now I've limited your option to C and D. Which among these makes sense?
So is it an average?
Average what?
Isn't it the average acceleration?
Why average acceleration? Why not instant? Why are we disqualifying the possibility of it being an instant acceleration? Because what you're saying something, I was unable to get what you're saying at the end. Nyumezi, why, what do you think? Yes, the answer is D. Reason being, we're given an interval, right? So average has to do with averages. Like they need to be an interval that you're going to be checking, whatever quantity that you're checking. Yeah, for instantaneous, it should be an exact velocity at an exact second. So that's the main reason why. Yeah, that's the main reason why the answer here is going to be D, because the velocity was over an interval of time and also an interval in terms of with regards to velocity, I mean. Yeah, so yeah. Then look at J. They're saying two boys are standing at the edge of a vertical cliff. One boy fires an air gun pellet horizontally. At the same time, the second boy drops a pellet at the edge of the cliff. The shot pellet and the dropped start at the same time or at the same height. Start at the same height from the bottom of the cliff. The time taken for the pellets to reach the ground is going to be what? What's the difference in the time it will take for these guys to reach the ground? What will be the difference? What's the difference, guys, here going to be? Let's say this. Yeah, so standing at the edge of the cliff, one boy fires the gun horizontally. So one boy fires it like this, then it falls like that, right? It doesn't go up first, it's just in the horizontal direction and it falls down. Then the second boy, use blue, saying at the same time the second boy just drops it off. So the second boy just drops it, it just comes down like this. Yeah, there is no increase in height or whatsoever. So they're covering the same distance coming down. The height is the same. So the correct answer here has to be D. Yeah, because they are all experiencing G. G going down is the same for both cases. So the outcome has to be the same. They reach in the same duration. So the correct answer here is D. So hope this is okay. Hope this makes sense. Then look at question 2. Attempt any 4 questions from the following. So we're going to do question number what? We start with question 2. Well, I thought this paper has sections, but it only has what this. Okay, yeah. So the one in section A and this part for choosing 4 questions. Yeah, so they gave what? They gave should be 6 or 7. Well, they gave 8 questions and you choose 4. Okay, so we're going to do 4 questions from here just for today. Yeah, so look at the first one. They're saying, attempt any 4 questions from the following. A ball is at the end of a 2-meter long string, swings in an arc as shown. The ball's speed is given to be 3.5 meters per second as it passes through the lowest position. To what height above this position will it rise before stopping? What angle does the string make with the vertical what? With the vertical when the ball is at the highest position. Yeah, so let's take note of what we have. The length has been given. L is given to be 2 meters. That's the first thing that you do. The ball speed, the velocity is given. The V is equal to 3.5 meters per second. Passes through it's this. They're saying to what height? So the length we know, the angle we don't. So let me remind you of those equations that you learned under this case. The first thing you have to remember is that you have T sine theta, which is equal to centripetal force. The centripetal force we're going to use here is mv squared over r. And we also have that second formula, which is T cos, which is always equal to mg. And you also have that formula that says sine theta is the same as r opposite over hypotenuse. So we have this case here. Yeah, so some people also divide the first equation and the second. There's another equation that they will give you on the cover page, should be something that looks like this. Velocity rg. There is something that looks like this. There's an equation exactly like this one. Yeah, they should have given us, let me check on the, at the end I think they gave the formulas. Is it? Here. Where is that part? They should be, they should give us, if they do ever, okay, here, these are the formulas, right? We know we have this, yeah. So now if you look at the equations that we have, what's the first thing that we can get here, guys? What's the first thing that we can find? What can we get first or easily? Anyone, guys? Anyone to just look at this? What can we get easily? Give you another equation. If this thing is swinging, right? So they're saying what angle does it make the vertical ball at its highest position? So this thing was swinging like this, right? So before it starts to move in a circular path, we assume the best case scenario that all the kinetic energy it had at this point had been converted to potential energy at this height. So we'll say half the mass V squared is equal to mgh. You can also assume this. Yeah. So if we assume this, meaning we're going to have what? Half the mass can be cancelled. No wonder the mass was not given at all. We have 3.5 squared is equal to 9.8. So cancel the m's. Then we have what? This is a height. We're looking for a height. So 9.8. 9.8. We can get our height. Your height is going to be what? Anyone who can punch this? Anyone who is having a calculator, guys? So if we get this to be our height, that's the only easier way I could think about in this particular case to get the height rise before stopping, right? So this is what we're having. Then they're saying what angle are we going to have? So for physics, just make sure that you indicate the units in your working, guys. I know I leave them out whenever I'm explaining, but you, in your case, as you are working them out, you have to show that this is meters per second squared as well, so that the answer is going to be meters when you're done. Yeah, you need your division here, right? You're looking for h. That's how the m comes about. Your dimensional analysis has to make sense, and because the smallest thing you're having here, all the numbers, the figures you're having were given to two significant figures, this guy, so even here the final answer should have been 0.63. That's what you give them, yeah, following the rules of rounding off, right? Then if they're looking for, so we know the what? We know the we can know what? We know the length of the string here is supposed to be 2, right? It was 2 meters long. So from the 2, you can subtract the 0.625 that we've gotten so that we are able to find this length here. Because with this length, you'll be able to get the angle. So what's the length that you have here? 2 minus this, 2 minus h, because h is 0.625. So 2 minus this, what do we get for this part? What do we get here, guys? 1.375 meters. So we know this is a 2. So we can now get our, even without getting the radius, because we're looking for theta. Theta is what? We have adjacent and we have opposite, right? So what can give us that? Is it cos? Is it cos theta, which is adjacent? 1.375 over 2. Yeah, so theta is equal to cos inverse of this. So what do we get? 1.375 over 2. So your theta is going to give us what?
Oh,
46.56. 46.56. Okay. Okay, so whatever you get, I'm not hearing the last part, but okay, hope everyone is getting this outcome here. Yeah, this is what we are supposed to get. Yeah. So this answers what you have here. So they'll pay attention to, this was a very simple question with a lot of marks. They'll pay attention to the rounding off, the units, and also how neat or the outline of your working. It should be able to make sense. Yeah, so your free body diagram must be indicated as well. So hope that makes sense. Any questions here? Anyone guys who has any question here? Okay, so it passes. So this is actually swinging. Yeah, the first thinking we did was okay, but it was a little bit too much because they said it actually swings, right? It's not moving in a circular path. So it's just swinging, coming from this point, let's call it A, to point B, H above the lowest position, right? Yeah, so this is not connected to centripetal force or whatsoever. It's just a normal pendulum doing its movement from the middle part to the other side. Yeah, so that's just what was needed to be done. Then look at this guy here is a projectile motion problem. So I'll get the free body diagram so that we don't get to look at it and we just solve it. Then we'll just pick the answers. So there is H, small letter h here. There is a 21 and 30. So 21, that's our velocity, 21 meters per second. The angle here is 30 degrees. So now we say whenever you're given such a projectile motion problem, we always first of all start by looking at the time for the rise, the first part of the journey. Of course, we have to resolve the u into the velocity into uy and ux, which is 21 cos 30. Then this will be 21, then sine 30. So first things first, get the time for the rise, the time from this point. Let me show it in red. The point from here up to there. Yeah, so the formula is just u, the initial velocity, then sine what? Sine theta over g. That's the formula that we use. They give you. So t1 is the velocity is 21, then sine, that's the 30, divided by 9.8. So the time here is going to give us what? Anyone to punch this? What do we get as our k? So our k, like I said, is this distance here, our height. So what do you get as your k? So you can just punch everything on the calculator at the same time to avoid wasting time. It will give you a number that you have to round off. What are we getting, guys? What are we getting? Okay, so someone is getting this. Okay, so just for the purposes of this, I don't know what other people are getting, but for the purposes of this, just let's go with this same answer. Yeah, so we need to get the h max now, the total maximum height. So we say h max. H max is the 16 meters plus the 5.2625. Yeah, so beauty, add the 16 to what you've gotten, because now we're looking for the total height. We already had our 16, we found our k, so we're adding everything. What do you get? Should be what? 5 points. This is supposed to be 21, right? 21,625, I think. Yeah. So this is the h max. So if you have the h max, we can proceed to get the time for the 4, which is our t2. Time for the 4 is always going to be given as what? Let me give you the equation here. It comes from h max. So h max, starting from here, since we are starting from this point where our initial velocity is going to be taken as 0, we are falling down, right? That's how we get our t2, the t4. So this thing is not pushed, meaning its initial velocity is 0. So this will directly be g t2 squared. Yeah, so in short, t2 is equal to 2 times your h max, then divided by g. Yeah, so t2 is the same as 2, the h max is 21.2625 divided by g, 9.8. We're taking g here to be positive because it's coming down, and of course time has to be positive by the time we're done. So the answer we should get here needs to be bigger than the t1 because this is coming from a higher height. So what do we get here? 3.2. Okay, so I'll take it like this, 3.2, meaning the total time of flight. The total time of flight is equal to t1 plus t2. So t1 plus t2, when you add these guys, you're going to get what? 1.07 plus 3.2. When you add them, you get what? Is it a 4.27? I'm not sure if everyone is getting this, but this should help us to be able to get the range. The range is equal to the velocity in the x times what? The total time of the journey. Yeah, so this is going to be 21 cos 30, multiply this, put it in brackets, multiply by 27. Yeah, so we get our range, which is the maximum horizontal displacement. Get it in meters. This is going to give us what? Roughly, anyone who is getting this? Yeah. You're getting what? 3 point what? Oh, 3.2 is the total time. Okay. What do you get for T2? I was looking for T2 here. And please, I forgot here, guys, here. The T2 is squared, right? So meaning even this guy here has to be, remember this was squared, right? Yeah, so if I make it the subject, I have to square everything this side. So what are you getting for T2? T2 only, this part here, what do you get? So now when you add this with 1.07, this is going to be what? 1.07 plus 2.10. This should give us what? Is it a 3.17? Yeah, something like this. I think 3.2, which is the same as 3.2. Yeah, so here we're supposed to use our 3.2 or 17, then you multiply everything here. What do we get? $68.2. 58. Okay, 58. Yeah, so this is going to be the range. So now we just come back to our question. After you've done all the working, the time of flight, we have it is 3.17 seconds. The horizontal range, 58, we have it. The maximum height, you have it, 21 point what? Is it 25 or 27? Yeah, so this is the best thing. Just solve everything. Then I'll just start picking them and underline your answers. So that's the best way that you can handle such a question. Is this okay, guys? Any question up to this point? Is there any question? Someone to just screenshot this part and send it in the group. So I'll end the class up to this point because I'm supposed to be in another class for these guys that are writing Math 2110. The engineering guys tomorrow, 21:30. So I'll end here for today. Then we'll proceed tomorrow during the physical class. This is your task for tonight. This is your task, a continuation of what we've done. This is 2 under projectile motion. Just attempt this question and send it to me on WhatsApp, or just send it in the group. Then people verify with what they've gotten. Yeah, so this is the question I want you to attempt. Take G to be that. The initial velocity, this is U0, that's 25. The angle here is 35. The negative distance here is 20. They've said negative 20. So let me see what you're just going to get. So just this part from question 5 A, B, C. Yeah, so let's end here on question 2. So tomorrow we continue with this part. This is mechanical properties of matter, thermodynamics I mean. Then we'll continue from here. This is linear momentum. Thank you so much for your time, guys. I'll see you tomorrow during the physical class.